All right, welcome back. Now that we understand how to analyze starlight, I want to take just a few slides and just a few minutes to talk about how we interpret it. So one of the things we didn't talk about measuring in the last lecture was stellar mass, and it turns out that this is actually a really important property of stars that dictates a bunch of other observable features. So measuring the mass of a star is non-trivial, right? It's not easy. We can't just weigh it, but there are some ways to do it. So the first is to look at binary star systems. So a binary star system is a system with two stars orbiting a common center of mass. And it turns out this is pretty common for stars. About 50% of stars are in binary or multiple star systems. So using Kepler's law, we know that there is a relationship between mass, period of orbit, and separation. We can measure a couple of these things. We can measure the speed from the Doppler shift in their spectra and the period from the radial velocity curve. If we have speed and period, we can tell the circumference of the orbit and hence the separation. And so once we have this information, we can tell the combined mass of the system. So we can do that by this equation here, where D is the separation, P is the period, and M1 and M2 are the masses of the stars. Not all stars are in a binary system though, but that is okay because we can also relate luminosity to the star's mass. Basically, the more luminous the star is, the more massive it is. And luminosity in particular is proportional to the mass of the star to the 3.9, so almost mass to the fourth. Luminosity can also be related to temperature and spectral class through the HR diagram. So you will do an HR diagram activity more to get acquainted with it. But you can see if we plot many stars on a plot of luminosity on the vertical axis here and temperature and spectral class on the bottom, there are many distinct features, right? The most obvious thing is this big diagonal line from the top left to the bottom right. So this is called the main sequence, and this is where stars spend 90% of their lives. Then there's also kind of stars up here, kind of in the upper right, very luminous, but also very cool, right? We're down here, 3000 Kelvin. So these are giants right here and supergiants. Down the lower left, we have some relatively hot stars, but they're small. So these are white dwarfs. We will talk more about them, all of this really, when we get to stellar evolution. Through modeling of star formation, though, astronomers have determined that the main sequence right here, it's not just a sequence of luminosity versus temperature, but it's also mass versus temperature. The more luminous a star is, right, the more massive it is. So this plot also shows how temperature and mass are related. That is all for now. I told you it would be quick. If you have any more questions, please shoot me an email or come by my office hours.